Yes, that's good. That's really, really good. Right. Thanks. So my name is Wei Jian. People, you should just call me Jian because my name is a bit difficult to pronounce, right, for someone who is not from the same country as me. But I've seen my name being pronounced in various ways, so don't worry too much. All that you need to know is that today, just focus on what I'm going to show today, all right? And because I'm going to do a lot of this screen changing, so it'll usually be more helpful if I shut down my video for a while so that you can focus on the screen and it will not take up much of a bandwidth, right? So I'm just going to just disable my video for a while. All right, so what are we going to talk about today, right? So I'll talk a little bit about my background, what is VBA, some basics of VBA, or I like to call them the ABCs of VBA, and also some hands-on examples that we are going to go through together, right? So I'd like to invite all my audience members who have at least your Microsoft Excel ready. And VBA is something that you learn from sharing, right? Not from listening to my lecture alone. So it's best if you can get Excel ready. If not, no worries. You can always reach out to me later and I'll show you or guide you on if you have missed any part of this journey, all right? So before we start, right, maybe a little bit of myself, right? So I call myself a coffee enthusiast and part-time engineer. So I really, really like coffee. My work experience spans 3 countries. So I work in China, Malaysia, and Singapore as different roles, but all related to chemical engineering. I was first a process engineer, then a project manager. Then I moved for operations for a year. I also work on digitalization and also being a technical services engineer in Singapore, which is a very large oil and gas facility in Singapore. And that is my latest role. Throughout all my experiences, I found that we spend a lot of time as engineers doing things that are actually pretty worthless or they add very little value to ourselves, right? And I'm really enthusiastic about how we can use automation to actually help us save our own time and be a more effective engineer. So my background comprises, I was an IBM data science professional certificate holder, which actually gave me the inspiration of some of the topics that we are going to discuss today. And I'm also a Lean Six Sigma Green Belt certified engineer. And that especially helps me to have a greater appreciation of how to do our things better with less time. My interests are mostly AI, digitalization, and coding, especially ChatGPT, which is pretty famous nowadays. And my hobbies are coffee, LinkedIn, and old school strategy games. So you can find me on LinkedIn very easily with my full name, Wei Jian Teoh. Just search on LinkedIn and you'll find me. All right. So what do I do now? I'm very active in knowledge sharing, just like Humza. We have a Facebook group with 8,000 members in it. We have a Telegram channel with 2,500 members. And we have a YouTube channel where I share a little bit about Aspen HYSYS, VBA, and Python, right? So if you would like to know more, maybe perhaps reach out to me later. But today we are going to focus mainly on VBA at this stage. So let's see what inspired me, right, to actually give the topic today. So surveys show, recent surveys show that we are wasting 40% of our time on repetitive tasks. 40%, right? That means almost half of the time we are actually not spending them effectively, right? We are actually using them to do things that are actually repetitive, non-value added, or they do not earn money for you, your company, or your business, or even yourself. And a more recent study even shows that stuff here shows that employees spend only 39% of their day on role-specific tasks, which is even worse, right, than the 40% that was found in the first survey. So can we program repetitive tasks to save 40 to 60% of our time? Right? Especially as engineers, we spend a lot of time doing calculations, and a lot of these calculations are very repetitive. So can we program this kind of tasks to save most of our time in doing them? Right. So that's what we're going to discuss today. But when we talk about find the easiest way to program is not easy for a lot of people. For some, it's very easy, but for some people, it's not easy, right? And there are a lot of programming languages in this world. There's Python, which is, as you probably know, one of the most famous programming languages. There's C, C++, there's R and Spark for data science applications. There is MATLAB and Octave for specialized engineering applications, including in chemical engineering. We have Java and JavaScript, which are used for web development. We have PHP, SQL, and Perl, which are used for websites and server-side applications. And finally, we have HTML and XML, so they are used to create the websites that we visit every day. So today we are going to talk about this programming language called VBA, right? So the first question you're going to ask, right, is where is VBA in this chart? Where does VBA belong to in this list, right? So if there's anyone in the audience who knows this, right, feel free to try to let me know your answer, right? So what is VBA and where does VBA belong in this list of common programming languages? Is it a part of another programming language, perhaps? Or is it a completely different programming language? So I'll give you a hint. The name itself, right? If you take the programming languages in the list and you try to shorten them, you'll find that one of them is very close to the programming language that I'm going to present today, which is VBA, right? So let me know your answers in the chat while I move on and let you know the solution to this, right? So if you have pretty much guessed, right? So Visual Basic for Applications is the full name for VBA, and it's actually derived from Visual Basic. So what is Visual Basic, right? So Visual Basic is a programming language that we use to run our Microsoft applications, including Windows, including Office, including Microsoft Word, Excel, PowerPoint. Every single Microsoft Office application that you have on your computer is programmed with Visual Basic, although we don't see it in real life because all this programming has been done by Microsoft and we are just using it. However, Microsoft has designed a specific type of VB called Visual Basic for Applications that allows us to do our own custom programs. And that is actually integrated into every single Microsoft Office applications. But for today, we are going to focus mainly on Excel, as that's something that we use for calculations, right? And I'm sure a lot of you know that Excel is used a lot in the industry. Even if you're a student, even if you're a researcher, even if you're a PhD student, even if you're an engineer, you use Excel a lot in the industry, right? And the main thing about VBA is that it allows for user-defined functions, or UDF, which I will show a few as this workshop goes on, and they are actually the key to success, right, in using VBA. And finally, if you have a programming background or a computer science background, you will recognize the fourth point here, which is that VBA is an object-oriented programming language. So what does it mean? I would say it's not important at this stage, right? I will discuss with you further if you wish to know more, but at this stage, it's not important to know what that means. However, what we need to know is that it allows us a lot of customization for us to use in our programming applications. So that's the key thing that we are trying to know at this stage, right? So why do we use VBA to automate repetitive tasks? As I mentioned, we spend 40 to 60% on tasks such as this. For example, we do numerical methods in our chemical engineering. We need to use numerical methods to solve a certain equation, and setting that up spends a lot of time. For example, in recognition, we need to, let's say, optimize the minimum or maximum of a function. And that's something that requires a lot of iterations. So we have to do it again and again and again and again until we finally converge to the result. Or we might even not converge at all and diverge. And that is a waste of our time, right? And when it comes to data analysis, there might be a lot of issues where our data is incomplete. We might have data which are blank values, or we might need to sort the data in some way, or we might need to find out the maximum, minimum of the data, and that can be done with VBA in a very easy way. And finally, last but not least, right, what happens with VBA is that we can actually disseminate it to our friends. So let's say we are working in a group, we can program a program in VBA, we can share it to our teammates. There's no payment required. There's no additional steps required. It's pretty easy to just take a file and share it to someone else. So your teammate doesn't need to learn programming him or herself. He or she can just work with you and collaborate with the same file using VBA. So these are the 4 key tasks that we are going to look at when we are using VBA. And I hope that can help you to supercharge your chemical engineering journey. So before we continue, I'm going to demonstrate some examples with Microsoft Excel. So it's best if you can download a copy of the worksheet from this link below. And I will also post a link in your chat box so that it's easier for you to access rather than trying to copy it out from the screen. Do let me know whether you can have the file. And if Humza, if you are able to help, perhaps you can upload the file if you can download it so that just that the other members in the call will not have to download the link itself, because I can't share the file in the chat. All right, so just let me know in the chat if you manage to open that link or you have some issues accessing the link. Just let me know in the chat. As it's quite important that you have this file to proceed. Otherwise, you will get very confused, I would say. All right, so I'll give you 30 seconds more. And yeah, see, Apple, thank you very much. You say link is okay, that's great. Karan, okay, that's great, that's great. That's really great, right? That's great, you're putting effort to actually learn something new today. And I hope all the other members in the call do that as well. Thanks, Mohammed. Thank you very much for downloading the file. Thank you, Umar Farouk, right? Sorry if I pronounce your name wrongly. Thank you very much. Make sure you can open the file correctly. All right, sure. See, most of us have the file ready and open, so let's move on, right? So let's move on. Okay, so before we move on to actually learn using VBA, it's important to know how to access it in the first place, right? So this is what we call the VBA IDE. So IDE means Integrated Development Environment. So the Integrated Development Environment is a way where we can use our skills to actually code in the functions that we want. So there's an IDE. So there's an IDE for everything. There's an IDE for Python. There's an IDE for C++. There's IDE for Spark. There's IDE for the R programming language. There's IDE for everything, and there's an IDE for VBA as well. Although it's actually it's less known than most of the other programming languages out there, right? So the IDE has three main windows. The first is the code window on the right-hand side. The second is the properties window on the left-hand side, which shows a lot of properties that probably look very confusing right now, but you get to know them in a short while. And finally, there's an immediate window where you can run code to test whether our program is working, right? So the other parts are not important for now, just ignore them. They're just going to focus on the important parts of the IDE. And if you have for some reason, you cannot find any of these three windows, right? So only these three windows are important. If you cannot find any of the windows, just click on view and you can re-enable them. So you might have accidentally closed them, right? When you're clicking something else, it might just be an accident that you have accidentally shut down the window. And I'm going to bring you through the four main components of VBA, right? Before you start programming anything in a programming language, it makes sense, right? To know the basics. Otherwise, you will not be able to write any code. You will not be able to actually read any code as well. And so it's pretty important to know the basics of VBA, which are variables, operators, functions and subs, and finally branches and loops, right? So I'm just going to stop sharing my PowerPoint screen, and I'm going to move into my Excel. So I'll just show you exactly how you can access the VBA link in the same way, right? Before we move on. So just allow me to stop sharing, and I will move on to my Excel screen. Okay, so I have my Excel here open and ready, and just to finally confirm before I move on, just to make sure that everyone is seeing the same screen as me, and everyone has this file, everyone has successfully opened it. If you have any issues, let me know in the chat before we move on. Otherwise, you are going to get very, very lost and you are going to get very confused, right? So just make sure that you have this ready and let me know in the chat if you still can't find it, right? Okay, so how do I access the VBA ID in the first place? That's the most important thing. We have to know where to access it, right? The issue is that on my screen here, which is the latest Microsoft Office Excel, it doesn't exist. The ID doesn't exist. And we will have to actually enable it ourselves. So how do you do that? You go to File, Options, Customize Ribbon. And on this right-hand side of the menu, look for this option called developer. So it's an option called developer. Tick it. Make sure that it is tick. So there's a tick beside developer. Then you click on OK. Then something magical will happen. You will see the developer tab on the top menu bar. So over here, you will see the developer tab. And this is how you access the VBA IDE. So if you are fast enough, you'll see that there's a Visual Basic button here. Alt F11 is a shortcut key to open the Visual Basic editor. So this is what we are going to use, right, to actually go through our Visual Basic. So I'll give you some around 30 seconds so just to make sure that you can access this IDE. If you have any issues, let me know in the chat as usual. Right? So I see Taslim, right? Taslim, have you managed to? I hope you have managed to access your Excel and you have managed to open the IDE. So this is how it will look like in a completely new sheet, and there's nothing in it, right? There's nothing in it. So if you notice, right, two of the windows are missing here, and to re-enable the windows, just go to View, Code. The window shows up. Now View, Immediate window. The bottom window shows up. So this is now exactly the same as I have presented in my slides, right? So just make sure that you know how to call up all three of the windows. So just to repeat again, View, Code to show the top window, View, Immediate window to show the bottom window. So we need all three of these windows, the code, the properties, and immediate, right? So let me know in the chat if you can't find any of the windows. It's very important that you know how to call them up because you really need them. Yeah, so just let me know in the chat if you have any issues. Okay, I see no issues. Yes, thanks, Taslim. Hope you managed to get that done. And thanks, Uma. All right, so I'm just going to go into my slides and I'm going to show you the first important aspect of VBA that we are learning today. Right, so allow me to stop sharing for a second and I will just go back to my slides just for a second. All right, Apple asks if it will be different in Mac, right? The shortcut will be different, the steps will be the same. The shortcut will no longer be Alt F11, the shortcut will be another key, but everything else will look the same if you are using the same version as mine, which is Microsoft 365. If you're using an older version, the steps are still the same, although it might take some time to find exactly where the buttons are. So I can't really help you if you have too old at Excel. So I hope that you manage to find it yourselves. Yeah, let me know if you can post a screenshot as well. Maybe I can guide you on how to just call up the different windows. All right. The first things first, right? Let's move on to the first item, which is this. Before we try to do anything in VBA, we have to make sure that we have the information that we need loaded inside the VBA IDE. And we do that by packaging them inside what we call variables, right? So they are containers for storing a piece of information. And these are the containers that we require before we even start doing any kind of operations, calculations, functions, whatever you name it. We have to ensure that our information is stored in a proper container before we do anything on it. Right? So there are many different kinds of variables in VBA. There are many different kinds. There are more than 30, I believe. But it's a very powerful programming language. But today, we are just going to introduce to you the important ones that we use day to day, right? I'm going to teach you all 30 or 40 of the variables in VBA. That's just too much for a day. And we can talk a whole day, 24 hours on that, and we will still have not finished, right? So we just move on to the important aspects of VBA. The first is to recognize the type of the variable. Before you start anything, recognize the type, right? So the type can be either, the first is a string. A string is basically any kind of text, right? So hello world is a string. I love VBA, exclamation mark is a string. The capital letter A is a string. A space bar is a string. And we create these kind of variables by using inverted commas at the start and back. So the inverted commas is very important, don't forget them. The second type of variable is integer. So I think you know what integers are. They are positive or negative, or they are positive or negative numbers which do not have decimal points. And 0 is a special case. 0 is also an integer. The third type of variable is Boolean. So we use this a lot in kind of true false logic operations. So the values that we have here are true and false, right? So it's a no-brainer. For numbers itself, we have in Excel, we have many kinds of variables for numbers. The most common ones are, I would say, single and double. So single and double. The exact difference between single and double is not important at this stage, but a simple explanation would be that the double variable type uses more memory when running the program. So if you have a lot of numbers that you need to, for example, in the millions, and you can sacrifice a bit of accuracy, it's best to use a single variable type. Otherwise, I've always recommend just going for double. So you see in the future examples like down the road today, all the variables I will be using the double variable type, right? So I won't want to sacrifice any accuracy for that. Finally, we have a variant, which can accept either string or double. So in case you have no idea whether that variable is going to be a text or a number, you can just leave it as variant. And later on, Excel will choose for you when it comes to putting in the numbers or the values in the variable. Then we have an array, which is a collection of elements. So this is similar to a array or matrix in MATLAB. If you know MATLAB, right? This is very similar to that case. And I would say it's pretty much more advanced than we are going to today. So today we are going to skip array. And finally, we have an empty variable type. So this happens when we have forgotten to declare a variable. So usually we don't create empty variables by purpose. Usually it's accidentally we made a mistake and we actually declare an empty variable. That variable type will be shown as empty. So up to now, I hope that everyone is still pretty okay. But the problem is that it's very difficult to memorize the types of variables in Excel. So what we do is I'm going to show you how to create every single variable that we are going to use today. And that's actually a much easier way of learning how to use variables. So please allow me to stop sharing and I will move on to the Excel VBA IDE where I will show you all the variables in the real environment. Okay, so I've come back to the VBA IDE and we are going to start playing around with some variables. So give me a second while I just try to make the text bigger. So it's easier for everyone here to see. And all right, so now it looks bigger, right? And just as testing purposes, we are going to declare variables by using the immediate window right here. So how do I declare a variable? I just click on it and I type in an equation. So let's try to declare an integer variable. So give it a variable name, x equals to 1. Then press enter. Only when you press enter, anything that you type gets processed. Otherwise, nothing happens. And to call back the value of the variable that we just declared, you use the keyword print, open bracket, x, close bracket. Then you press enter. And then you see 1. So this means that I've successfully declared the variable x and assigned the value of 1 to it. Right? So nothing special. This is just a very basic programming. If you have a background in Python or MATLAB, you have known this, right? So let's declare a string variable. So let's say y equals to, and remember that when you declare a string, we have to give it an open and close inverted commas. And then we have to declare the variable inside the commas. So let's say hello, exclamation mark. Press enter. Then let me just recall the value of this variable, just to make sure that it is done correctly. And you see the word hello, all right? So that's good, we have managed to do it. Let's declare the third variable, which is the value of pi up to 5 decimal places. Let's try to print a variable z. So we get a number, right? So these are the basic, the basic variables. And you can also have a true false variable, but we'll go through that later. How do I know what variable is being declared? We use that by using the keyword called type name. So let's say I would just want to know what type of variable is X in this case. So I'll just type print, open bracket, type name in one single word, variable name, close bracket. Sorry, I type a third bracket. And you press enter, it shows integer. So this is basically the type of the variable X, which is an integer. And then I can do that for Y, which is a string. So this is as we discussed previously. And then we move on to print type name Z. So that's a double. So remember that a double is a representation of the decimal number. It can be single or double, but the default that Excel will assign is double. So that will be the same that we are using for this case, right? So if you have any troubles, let me know in the chat whether you have issues, your errors popping up and so on. Let me know if we have them. Otherwise, I'm going to move on to the second category that we have to know today. Because declaring variables is useless. We have to be able to do something to them, right? And that will only be useful to us. So I'm just going to stop sharing again. And I'm going to move on to the PowerPoint slides. Oh, Taslim says, good, sir, understood. Yeah, thank you very much. Thanks for your feedback. Really appreciate that. At least I know people are following the conversation, and that makes it easier, to understand. All right. So the next thing to know, after we have declared all these variables, so there are also other types such as the date, the currency, basically anything you can put in Excel is a type of variable. So for example, dates and currencies, right? Some people use that for accounting purposes. Some people use that for, I don't know, sales or business management or that kind of stuff, right? But in this case, we're going to ignore dates and currencies because we are engineers and we rarely work with dates or currencies. So let's move on. The second part we need to know is operators. So how do we manipulate the variables that we just discussed in part one, right? So when we manipulate variables, we can do mathematical operations on them. So plus, minus, multiply, divide, and so on. We can apply exponent. So just to clarify here that the exponent symbol is this. Yeah. If you are used to another programming language, they use a different symbol for exponent and you might get confused. But in Excel, it uses this symbol, which is also the same symbol in Excel itself, right? And then you can have the assignment operator. So I want X to be equal to 3. So the equal sign assigns a value of a variable. So we can also use that as a comparison. So I can compare whether X is equal to Y or not. So if I want to compare if X is not equal to another variable, I use this symbol, which is the less than and greater than symbols combined. So this means not equal to. And this is unique to VBA. No other language uses this kind of symbol. We can also do comparisons by greater than or less than, and also greater than or equal to and less than or equal to. Right? So I think this will not require further explanation. It's just can be understood easily, right? And the final two variables here, the final two operators here, are for logic statements. So we want something and something, something or something, something not something. So these are more advanced statements that we will not use for today. So let me know in the chat if any issues are following up. Otherwise, again, I'm going to show you in IDE how we use these operators. Right, Kevin says understood. That's great. That's great. So just to confirm that everyone can understand what I'm saying and my accent, right? Because I've been giving talks to people from 15 different countries, and I have some feedback that what you're saying isn't English, so I have no idea. So probably we might have a cultural barrier or something. But just let me know if you are having trouble understanding me, and I will speak a bit slower or clearer as required, right? So we are back in our IDE, and the first thing I go is I'm going to select everything here and just clear it, delete it. So we start again, right? So how do we use these operators? So let's start with the easiest that everyone knows, right? Which is mathematical operations. So I'm going to declare X is equal to 2, enter, Y is equal to 3, enter. And we are going to play around with this, right? So let's say Z is equal to X plus Y. and then I'm going to print z. So I get 5, right? So let's say a equals to x divided by y, print a. So you get 2 out of 3 or 0.6667, right? So you notice that in this case, the double variable only remembers around 16 decimal points. So if you go further than that, the decimal points get thrown away, and that will affect the accuracy of your calculations if you use a lot of decimal numbers. So this is something that you have to take note of, and this is something that we call floating point precision. So you can Google what is floating point precision to know more about how exactly Excel does all these calculations. But you have to be careful if you are going for very, very accurate kind of calculations. But for most cases, we don't care, right? And you can also use the exponent operator. So 2 to the power of 3. And then I'll just print b. So you get 8, right? So this is nothing special. And I believe that everyone knows what I'm typing here. So let's go on to the next operators, which are the comparison operators, right? So we can actually compare them directly, or we can use a new variable to store the result of that comparison. So let me give you an example, right? So let's see if Excel knows whether x is equals to y. So we know the answer is definitely not, because x is equal to 2, y is equal to 3. Definitely they are not the same. But let's see if Excel can do that for us. So I'm just going to type in print x equals to y. So do be careful, right? This does not assign y to x. This is actually a comparison operator. So when I type enter, it says false. So that's good. At least Excel knows basic logic that x is not equal to y. I can also create a new variable to save that comparison result into it. So I can say c is equal to this. In this case, I need an open bracket, x equals to y, close bracket. And then I can print c. And I can also check the type of c. So you find that this is a new variable type known as Boolean. So this means a true or false value. And we can also use Boolean variables in operations. For example, I can put in d equals to true or false. Then you can print d. You get the value true. So if you know the reason that this value is true is that how do we understand how Boolean operators work? That means how AND or OR works, right? So if you don't know, I can give you a few more examples, and you can see how the AND and OR operators work. So let's say E equals to, oops, I made a mistake actually. I realized I print the previous value. Let me just print E instead. So F equals to true, false and false. Print F. G equals to true and true, print G. So the AND operator only shows true if both values are true, otherwise it's false. And the OR operator only shows true if one or two of the comparisons it being used is actually true. So that's basically the basic logic of AND and OR. And you can also nest them in more brackets. For example, I can compare them in this way, true or, and then I open a bracket here, and I have a true and false here, and it will do it based on the inner bracket first. So as usual, as a mathematical operation, right? You can also prioritize which statement do you want to do it first, and you can see the difference in the two answers if I have actually moved the bracket to the first comparison, and when you do that, you get a different answer. Yeah, so these are the operators that we have in VBA. There are a lot more operators, but we'll not go through everything in just 1.5 hours, right? All right, so let me know if any issues. The most common issue that I've been doing this for quite a while, and the most common issue here is that I get a variable not found error. If you get that, right, usually it's because you have accidentally typed in the wrong name, or you have typed in the wrong variable letter. For example, capital G and small letter g is considered different in VBA. So you might have, if you have declared the variable as capital G, you have to use capital G. Otherwise, it will say variable not found, right? So you have to be mindful of that. So let me just go back and we'll go on to part 3, where we finally create a function that we can use in Excel, right? So let me just stop sharing and go back to my slides. As usual, any issues, please let me know in the chat. All right, well, no issues. Thank you very much, Jesus. I did subtitles because I'm in a noisy environment. Yeah, that's great. I hope the subtitles catches my Malaysian accent. Sometimes they don't work that well, but I hope you can understand me. Thanks, sir. Thanks very much. You can understand me. That's great. All right. So let's move on. All right. So we have known about variables. We have known about operators. Now it's time to do something using both of them. And how we do that? We create a function or a subroutine, right? Or a subroutine is also called a sub. So sometimes I'll just call a sub in the subsequent of the workshop, and just not be confused. I'm not referring to a submarine or something, right? It's actually referring to a subroutine. So the difference between a function and a sub at this stage in time is that a function has input and output. A function has input and output. And the term to use is call. I'll call a function. I call function 1. I call function 2 with this input, with input A, B, C. So that's the terms that we use. In a subroutine, there's only an input but no output. And usually we use the term run. So I would like to run subroutine 1. I would like to run subroutine 2. So if you're familiar with the term macro in Excel, right? Macros. A subroutine is also the official name in VBA for a macro. So if someone tells you I'm running a macro, he or she is running a subroutine. It's actually that simple, right? So a function can be public or private. So that defines on how you can access it and where you can access it. So for most cases, I will just call it a public. So I just want to access it anywhere in the whole Excel. I don't want to just limit myself anywhere. And if you have experience from another programming language such as C++ or MATLAB, you have to know that in Excel that it is optional to declare the variables before use. It's optional. You don't have to, but it's actually a recommended practice to do that. So just to ensure that you have declared all variables properly before you do anything, so that you don't have issues down the line. Otherwise, you might have issues after a few days of using it, and then you realize that you have forgotten to declare this variable, and then you're trying to use it. It's also possible to set this option called option explicit, which will then force you to declare all variables. Then if you set this option to be active, it will force you to declare all variables before you use. Usually I don't do that for convenience reasons, but it's something that you can take, you can just remember if you want to use that, right? All right, so let me just go back to my IDE and show you these two very simple functions here. So the first function I'll just call test function, and then it just prints out something that I want it to print. And then the second, I will just ask it to print something else, but I will make it in the form of a subroutine just to demonstrate to you the differences between the function and the subroutine, right? So I'll just go back to my IDE again. Okay, here we go. We are back in the IDE. And now we are going to finally move on from using the immediate window. So let me just delete everything here as usual. And I'm going to reduce the size a little. And I'm going to move to this code window at the top. So as a window is called code here. So you probably know that this is where you type in your code, right? So this is where you type in your code. And let's start by defining a new subroutine. So subroutine is an easier thing to understand. So I'll just define a subroutine here. You define a subroutine by typing the keyword sub space, then the name. So I just call it test sub. The capitalization matters, but usually I'll just put in a capital letter here just to make it easier to read for the user. And when you start typing the name, an open and close bracket will show up. So this is where you put in the input of the subroutine. Then go to the end and press enter. If you've done that correctly, you will see Excel will create this new line called end sub for you. So that means Excel has recognized that you're trying to enter a new subroutine, and Excel is asking you to type in whatever code you want in the middle of these two lines. So it has to be in the middle of these two lines. let's say I just want to print, I just want to show the user something, right? So I do that by typing debug.print. So when you are typing commands, you get some helpful windows from Excel. So like recommending you to choose some of the more commonly used commands. So in this case, I'm just going to use debug.print. And this is just going to tell the user to say hello. So very simple example to start off. And this is now a complete subroutine. There's nothing much here. There's opening line that defines a subroutine name. There's an ending, the closing line, and then there's some code in the middle that is part of the subroutine. So how do I run this subroutine? I click on the play button here. So you can see it's called run sub or user form. So run sub is something I want to do, right? So you click on run here. And you can see that it's actually called the macro name. Then click on run. So it prints out the value hello. And that's it. So because this is what I coded the subroutine to do, right? So that's what it does. Nothing much on that. Okay, so let's move on to a function, right? To a function. So I'm going to just go to the end here, a new line, and I type in function. Again, I have to give it a name. So I just call it test function, open close bracket, enter. So you now see a new line being created by Excel because Excel knows that you are actually creating something different. And you have, again, you have to fill in the function code in the middle of these two lines. Again, this function will just do nothing but print out something. So in this case, right, let us do something different. Let us give the user a customization option, right? So the user can actually customize the word that the user wants to see. So in this case, I'll put in the input called word. So word is a variable name. So again, I can do my definition. I can actually declare word as string. But because I did not have the option, set to option explicit, this is optional. So I can actually delete this line and it will still work. But this is usually the usual way of defining a variable. And in this case, I'll ask the function to just print out the word. And if you remember what I mentioned, a function requires an input and an output. So what do? I have already the input. This is the input. Now I want the output. The output is the function name. So what I have to do is actually I have to assign whatever I want to do to the function name. So for example, I have to put in test function equals to word. So basically what this does is just to assign the word to the output. So it's actually telling Excel to just make the output equal to the input. That's it. And once I've done that, right, I cannot run this function because the function cannot be run. I can only run a subroutine. So I will have to call that function by using some of the methods that we discussed previously, right? So let's do that. For example, I can type print test function. And let's say hello. Sorry, let me just change this back to hello. Just to demonstrate the differences that we are going to show you. Let me just, for example, let me just type in 2 + 2 = 4. Then close bracket, close bracket. I get an error saying that, sorry, let me just show the error again. I get error saying that sub or function not defined. So what's happening here is that we require two things. First, we have to save the file in a macro-enabled workbook. And secondly, we have to make this function available to the whole workbook. So if you notice on the properties window here, you can see that sheet 1 is selected, which means that this function is only available in sheet 1. And that is actually a problem because I want this function to be available anywhere in the workbook. So what I'm going to do is I'm going to just select this one. and cut it, paste it in this workbook. Double click on this workbook, you'll see a different code window, and I'll paste it here. All right. So the next thing I'm going to do is I'm going to save this worksheet. So let's say file, save. And when I save that, right, what happens is that you show an error saying that if I continue, I will lose all my macros, all my VBA coding. So what I have to do is I have to save it. We have to save it in a macro enabled workbook. How do I say, a macro enabled workbook file format. So I'm just going to show it here. So choose this one. And let me just rename it something else, so I don't replace the template. So I just call it demo. And when I do that, my function, my Excel file will change extension to XLSM. So this shows that this Excel file now has the capability to use VBA, and that's pretty important, right? So that we know that your VBA code is safe. Otherwise, your code will just be gone, and all your time you wasted, all the time you spent on it will be wasted. So now let me just try to let's save this, and let me just do that again. Let me just use a more simpler one, test function word. Let's say hello. This is good. This seems to be a little weird. It should be registering. You just try adding the word public here. Save it. And let me just try that. This is pretty weird. Let's try that. Let's assign that something else. Let's give it a name. Let's make this function and save it. Now this is a weird bug that I'm having. As anyone in the chat, let me know in the chat if you have encountered the same issue. If you have done it correctly, right, you should be able to see this this hello and then the word show up in the chat. I may have to skip this example while we move on to something, as I seem to be having a bug in my software. So just let me know if you have any issues. Otherwise, I think we have to move on due to time constraints, right? So let me know if you have any issues. If you have encountered the same error as mine, I don't think you should. Okay, let me just go back to my PowerPoint slideshow. Uma says, I'm using 365 version of Excel. In this version has XLTM. Yeah, some versions have slightly different extensions, so it's good to know sometimes that you're using a correct file. All right, so let's move on to bunches and loops. So when we have a function, right, what's important is that we need to be able to do something when something condition is satisfied. A condition is satisfied, or I'll do something when we have a certain number of times. So the first is what we call a conditional branching. The second is loops. So I'll just show you quickly in the IDE on whether we can have what we can have when we use this conditional branching and loops. Okay, so let me just go to my IDE again. Okay, so just now when I mentioned about functions being, I can just share these functions to other people. it's not correct to put that in. I should not be putting it inside a sheet or this workbook. If I need to share it to someone else, I have to create what I call a module. So let me just do that right now. I'll just delete everything here. Just delete everything here. What you do is you should look at this this pane. We'll click on empty space. Click on insert module. Then, and I will close the other previous windows just to show this current one. And this is where I code my functions, and this is an easy way to keep track of them, right? So what I can do here is I can click on module and I can rename it. So I can just call it branch example. So that will allow me to remember which is which. And I will show you a simple if-else statement here. So let's say I will create a function that detects an input, let's say a number that the user is going to key in. If the number is less than 0, then say hi. So this is the minimum for if-else statement. We require one if. That's a minimum. So let's try that. So let's just assign this to the function. Made mistake. Okay, that should be easier. So let's just print a bunch example. Oops, I think I couldn't do that noise. Let me just okay, let me just do a simple print statement here, and let's see if it works. Just use some subroutines probably easier to at this stage. So let me just call a bunch example. Sorry, let me just run bunch example with a number. Let's say -1. Oh well, let me just try to troubleshoot that. Okay, let me just try another method. Let's try that. Okay, I'm going to save that and then just run this. Okay, I think I've got an issue with Excel. Just give me about 3 seconds while I switch over to my another device, and I'll see you in a second. Okay, just to confirm, everyone can see my Excel screen now. And I have redone the example here. It seems I have some Excel. I have Excel bug in my other laptop here. So I'll just type in a subroutine branch example with input as num. And if num less than 0, then debug print high, then end if. So if I call this subroutine by typing in the name with a number, I get high. And I can then add on by saying that else, for example, else, then I will just debug. Goodbye. So let's just use a simple example here. And let me just save that. And let me just call this subroutine with a different number. Let's say 0. Oops. Sorry, and if has to be down here. Okay, then let me just call that again. And in this case, I've actually triggered error, so I actually have to click on reset here and do that again. So I get goodbye. And this is a very simple example of a branch. So let's move on and let me show you how you can use that also as an example for doing a loop. So in this case, right, let's use this simple example here, where I will just have Excel VBA print out the numbers 1 to 10. That's it. So for every line, I want for every number 1 to 10, I want it to print out counting down, this statement counting down here, and then I want to print out the number itself. So that's something I'm going to do right with Excel. So I'll just stop sharing this and let's go on to our ID. All right, so let me just create a new module, module 2, and I will walk you through on how we are going to do that. So again, just call this a sub, let's say loop example with an input we call I, and then let's just use the term number here, standardize it, and dim I as integer. For I equals to 1 to number, let's print out the statement counting down, and let's print out the number itself. Okay, so we are ready to go. Let's just call loop example with 10. Oops, I forgot a line, which is next. Where we put in a for loop, it must always have next at the end, the code itself. All right, right here, it's resetting. So you can see Excel prints out the numbers, counting down 1, counting down 2, 3, 4, 5, 6, 7, 8, 9, 10, as we define. So this is very simple loop, where we just have Excel count out numbers from 1 to 10, and just have them printed out in the debug window. All right, so that's a very simple examples that we have. So we have around half an hour half an hour remaining. And if any questions, just let me know in the chat before I move on, as usual. Any technical issues, let me know in the chat. All right, so I just stop sharing here and move on to my slides. All right, so to give you a real example, right, of how to create a function in Excel itself, let's play a game. Very simple game, right? Let's play a game. And if you can follow this example and create this game, you have actually basically mastered all the basics of VBA. And in the end, I will show you a little about how we can use Excel to do some chemical engineering related activities, right? So let's use a simple game here. I think most of our audience members have seen this kind of motivational post, right? Where you will assign a letter, a value, and we try to find out which of these is equals to 100. So some people say skills is not only 82, knowledge is only 96, hard work is only 98, attitude is finally 100, right? So let's see if we can make a game that calculates the value for each word here. So for example, skills. So this game or this function, you're able to calculate the value of each each letter, so SKILS, and then we get this. It then tells me what is the total here. All right. So before we write any function, it's best to actually sketch out the steps that we want to do before we write, and it's good to have this on a piece of paper, on a notepad, on something on your phone or something. So first, the first step is I want to break up this. Sorry, I want to break up attitude into its letters, A, T, T, and so on. Convert each letter to a number, to its respective number, and add them up. So 120 plus 1 equals 21, 21 plus 20 equals 41, and so on. Then finally, I want to know the answer. I don't need to know anything in the middle. I just want to know the answer. And this is actually an important step that many people forget. So ensure that these 4 steps are what we have, right? So let me show you in Excel how do we do that. How do we code this game? All right, so let's go back to our IDE here. And okay, so we are back in. I'm just going to create a new module called, let's give it a name called example1, ex1. And I'm going to give it a function. So first thing first, of course, use a keyword function. Then the function name, let's call it a word score. And the input is the word itself. Right, no issues here. Then next up, we need to read every single word, every single letter of the word. And we do that by using the keyword called meet. But before we do that, we have to actually have a counter that remembers the position of the letter that we're trying to read, right? So let's start this. And we also need some of a for loop to actually loop through the whole code so that we can ask Excel to repeat the addition for each of the letters in the word. So let's take it step by step. The first thing is to read the word itself and put it. So let's assign, let's declare a new variable. Let's call that a current letter as a string. Let's just call it a current letter. And I want to read out this word. So I can use it a print statement just to make sure that Excel reads the word correctly. Okay, so let me just call that print word score with the word attitude. Okay, let me use a different name. So let's call that word score 1. Okay, so the first step is done. Excel can now recognize the word and return me back the word. So that's attitude goes in, attitude comes out. Okay, that's good. That's step number 1 done. The next thing we need to do is to slice up the word into its letters. So we do that by using the keyword meet. But we need somewhere to store the letter. So I'm just going to use that as a current letter. I use this current letter variable to store that. And I realized that actually I need the starting position. So start as long here is actually the starting position of the word. And I will need a new variable to store that. So I'll just use I as the variable to store the iteration. Okay. And I will then do that. I will then use a for loop equals to 1 to 1, 2, 3, 4, 5, 6, 7, 8 to 8, right? And for the numbers 1 to 8, print out the current letter and just print out 1 letter. And then we have a next here. So that will end the for loop. And then let me just put out a print statement, the debug statement, so that I know which letter is being read at this time. And I'm going to disable the previous debug statement. So you can do that by actually putting an apostrophe. So this is the apostrophe actually defines a comment. So when I comment out this line, it will not be processed by Excel. So let me just see if this works. Yes, it works. So Excel now knows how to read each letter individually. So that's our second step done. The third step here is to have Excel convert these numbers into convert these letters into their respective numbers. So let's see what kind of numbers Excel is using at this stage. So what do we need is, again, we need sort of a temporary variable to store that. So let's just call it a current number as an integer. And just edit this line where we convert the letter into a number. And we use that, we do that by using the keyword ASC, which is actually a built-in function that converts a letter to a number. Although we don't know at this stage what number that is, right? We still don't know what number that is. So let me just do that. And I will comment out the previous debug print line. And I will show the current number. Okay, that now let me just uncomment that. And let me just delete everything. And then run that. So we see Excel has changed the letters into some numbers, although the numbers are not what we are looking for. The numbers somehow start from 65 as A, and then it goes on. So we have let's say T as 84, we have I as 73, and so on. So there are many ways that we can what we're going to do is we're going to make A to become 1. And there are a few ways you can do that, but the easiest way is to realize that this is actually just 64 plus the number that we want. So the easy way to do that would be just to subtract 64 from whatever the number that Excel is giving us. And let me just call that again. So yes, that's it. We have completed the third step, which is the second step, which is to have Excel convert each letter to respective numbers. And then we can have, now we just need to add up all these numbers together. So I will just define another variable to store the current total, also as an integer. And then I will have here current total equals current total plus current number. So basically what this does is to have the current number being added into the previous total. But since I have done that, right, I will have to define the original value of the current total as 0. Otherwise, the first step will fail, as it will not be able to find where current total is to add on the new number. Comment out this line with a new debug print statement for current total. All right, so let's try that again with this and let's see what happens. Yes, we have managed to complete step 3, which is to have the totals of each letter being shown on the screen. But the last step is I just only want the last total. I don't want any of the intermediate steps. I only want the final total. And we do that by assigning the value that we want to the output. So before the end function statement, I'm just going to add in the function name, word score 1, and then have it assigned to the variable, assign the variable that we have currently to store the current total into the output. And then we just delete this. And I'll comment out the previous line so that you don't have too many lines of useless data. Just going to save it and press enter. And then we get 100. So basically, we have managed to complete a whole function in VBA almost from scratch. We have completed a whole function from VBA. So you might ask, right, what's the use of this? What's the use of this? So what's the use of this is, we can actually use it in our Excel sheet. So give me a few seconds where I show you what happens when I try to use this function in Excel sheet. Right? Give me a few seconds where I stop sharing. So I just give me a few seconds more while I reopen my Excel again. All right, here we go. Okay, here we go, and I have my worksheet ready here. And if you look at example one, you see what I'm showing here. So let me just quickly share that. Okay, so you'll see that I've created a worksheet here. And I have created a few words in these cells. And I want to calculate the score in these cells, right? So let's try out what I meant here. What I'm saying here is that whatever functions you create in the VBA, you can actually use them in your Excel sheet, right? So this is actually part of the user-defined functions that I was talking about previously. And how do I call that function that I just created? You call it the same way as any other function in Excel. For example, you type equal sign. Okay, let's use this equal sign. Then just name the function as word score one. So you just type in the function name. You see that word score one appears here as a recommendation. Then you open bracket, and then I just type in the word that I want. Enter. Wait, 0 doesn't make sense. Aha, wow, and made a typo in my code. Sometimes even a single typo can make a function go haywire. That's why it's great to check your work sometimes and before you run any functions. Let me just resave it again in a macro enable workbook. And here we go. All right, let me just rerun this formula again and let's see if it gives me the correct result. Sorry, let me just. Another typo. All right, got it. All right, let's show you again. My apologies. Let's say word score one attitude. You get 100. So this is how you call a function that you just defined inside the workbook, right? And you don't only have to manually type in the word, you can actually use it as a normal function. So for example, I just want to calculate all the words here in one shot. So what I can do is I can just call the function name, word store one, bracket, select the cell, close bracket, enter. So you get the correct words. You get the correct scores for each of these words. So which parents, I will leave it as an exercise for you on how do we actually calculate that properly. Because if I just drag it on this formula, it doesn't consider the spacing. So this is actually not the correct way of doing it. I will leave this as an example of how you actually try to modify the formula so that you take care of spaces, take care of unique special characters and so on. So that's actually a lot of things to learn about that. So this is our first example and the first real function that we just created. And I've also added a few more examples that I'm going to show you quickly on my spreadsheet here. And don't worry, right? In the end, you will get the copy of the slides. You'll get a copy of the slides and also this worksheet. So you'll be able to work on these examples at your pace so that you can learn more about how you use VBA to save your time as a chemical engineer, and also to practice so that you get better at it. So example 2 here, right? I have a chemical engineer who works in a company, and I need to calculate in this company, this chemical engineer has to calculate the heat capacity of the few substances. So I've already provided the heat capacity data here. So I need to develop the heat capacity formula to calculate in these cells. So I will quickly show you the example of how the answer to this would look like, and you can have a look. Stop sharing. We share on this other device. All right. So I'm sharing to you how I would do it in VBA. I created a function called CP, where I can choose a substance that I want as an input, the temperature, and the formulas are programmed. So that for oxygen, this is the formula for oxygen, the constants A, B, and C in the equation, and then the minimum and maximum temperatures. And finally, I calculate the CP and return to the user on what is the CP of the gas. So example of application here, so I'll just show you in this case. So we can have the CP here. So let me just try recalculating this as a demonstration. So I will type in the equals sign CP, bracket, the name of the gas, and the temperature I'm calculating at. So I get 28.395, which is the heat capacity at constant pressure of oxygen at 100 degrees Celsius, with the units of kilojoule per kilomole per degree Celsius. So you can see that if you create this kind of sheets, you can actually make your chemical engineering life much easier, because you can reuse it. You can use it for all the common gases, all the common substances, and then you can use that to calculate other properties like enthalpy as well. And you can also use it in combination for other calculations. For example, calculate the temperature at which the CP of air is 17.2. So let's say I need to know exactly, right? What is the CP? The CP of the mixture at 0 degrees Celsius is 16.3. For example, I need to know the exact temperature at which the CP is 17.2. I need to know exactly at what temperature. What I can do is I can actually code a formula that calculates the CP for this mixture of O2 and N2, which is basically air. And I can use a function known as goSeek to actually gain the result that I want. So I will demonstrate to you how I use goSeek to get the results. So I'll click on the data tab here, data, what if analysis, goSeek. So you see this window show up. So this is the goSeek window. And I want to set this cell, set cell to the CP of mixture. And I want it to be exactly 17.2. I want it to be exactly 17.2. And I want to vary the temperature that I'm using. So by changing cell, I select temperature. I click on OK. So I get the result that I want, which is at 426, around 427 degrees, I get the CP exactly 17.2. So this is an example of how you can actually integrate the functions that you created with VBA into your normal daily Excel calculations. You can use any Excel function to interact with the functions that you just created. And that is the main power of VBA, creating user-defined functions. Yeah, so because of time constraints, I'm just going to quickly go through the 2 other examples here that via my slides. And I'm just going to stop sharing for a while. While I'll go through some other ways that we can use Excel to help your life become better. Right, so let me just quickly move on. I'll just keep this extra credit for now. And let's go to heat capacity. So there's a definition of heat capacity, and I just show you the equations of how you can help Steve calculate the CP of O2, N2, and carbon dioxide. All right. So these are the formulas and constants that I provided, and the functions I create, which is CP bracket, substance that swing the temperature as a double. So we can also use VBA for numerical methods, such as this bisection method, where we need to solve an equation, the roots of the equation of the function. So there are many ways. For example, there are bisection, there's a secant method, there's a Newton-Raphson method, there are many other methods. So the simplest is the bisection method. And the theory is that we can guess a range, the guess 1 and 2, where the root that you're trying to find is actually between these two guesses. And then you try to slowly narrow down the two guesses so that we hit on the root itself. And if I'm able to use a paper, I would have to do all these steps myself, all these steps. I have to find the midpoint, calculate the values at the midpoint and the upper and lower values, check where the root lies, and then repeat 1 to 3 until the maximum of iterations is reached. So I have to do that again, and again. So if I cheat and use an online calculator for this specific equation, negative x squared plus 50x plus 50, I get two solutions here. So if I'm to use I used to do it manually on paper, I will have to write down all these lines. So it turns out that it's about 18 lines to get the answer that I wanted, that's given by the online calculator. The next and last example I would like to show you here is also a numerical method where you can calculate the area under the curve using VBA. If you are talking about designing a reactor in chemical engineering, the equation that we use is usually an integral, and we are not able to solve this directly. We have to plot out the values here, then integrate the equation via a numerical method. And this is known as a Levenshteil plot, So we can actually get a good estimate by integrating the area under the curve. And this is something that can be done in VBA as well. So we can get a function called reactor volume, where we actually calculate the area of the curve and then add them up, so that we get the final area of the Levenshteil plot, and then we get the area of the reactor that we want. So this is shown in example 4 here, where let me just quickly show you. So example 3 is the bisection method. So I've actually shown you the manual method of calculating the bisection method. So you can see how many steps it takes. But if you were to code in the bisection method, it only takes one step, only one step. You just have to type in the function name here, you get the answer. For example 4, I have an area under the curve. I have given you the values plotted here. And again, if you were to calculate manually, it takes 10 steps or more than that, depending on how accurate you want your answer to be for the Levenshteil plot. But if I were to code it in VBA, the function takes only one step. And that's how a lot of my time is spent. I don't have to spend a lot of my time actually doing the manual coding of the equations. I can just use one step and that's it. That is how I get the reactor volume. So I'll leave example 3 and 4 as exercise for you. So you can go back and try it out when you have time, and let me know if any questions to actually get the solutions that we are looking for. Right. So I'll move on to my last slide, and then I'll pass the floor back to Humza for the end of the webinar. So I'll just show my last slide in this case. So key takeaways for today, right? The key takeaways I want everyone here to bring home is that everyone can code. Everyone can code in VBA. You just need Microsoft Excel, which almost everyone has. Not necessarily you have to be a computer science graduate or a computer programmer to learn. VBA is also a very good starting point to learn different languages, because fundamentally quite a few of the languages are very similar. VBA, for example, VBA, Python, MATLAB, all very similar languages. So if you know one, basically you know all of them. And VBA is one of the simpler ones to learn and start with. The 4 elements of VBA that we are looking for: the variables, operators, functions and subs, branches and loops. Just remember all 4 of them, and you will know your basics of the VBA. And that's all, folks. Don't wait, just begin your journey now. And let's I'm happy to take any questions, last minute questions that you have. If not, I would like to invite you to connect with me on LinkedIn, and I'll drop me an email if you need any more, furthermore data or information regarding how to apply VBA in your daily applications. So I'll pass the floor to Humza, just if you have anything to add. Thank you, Humza.
Thank you very much, Wei. Thank you for the great webinar and all the interesting information and for sharing your knowledge about Excel. You truly are an Excel wizard, so thank you so very much once again. But like Wei said, does anyone have any questions they would like to ask right now? I guess not, but just like he said, if you have any questions, then feel free to reach out to him on LinkedIn, and also do remember to subscribe to the YouTube channel that he mentioned, because as you already have gotten the idea, he is an expert in Excel, so it's always a good idea to have someone like that in your contact list. But it goes without saying, once again, thank you very much, Wei, for all the information, and thank you to all the attendees for attending the webinar today. And please do visit www.ChemEnggLife.com and do keep a lookout for our future webinars as well, if you would like to attend them. And do remember to visit our YouTube channel as well and subscribe to that so that you can stay updated on many of our other initiatives. But having said all that, I think there is actually one question. Yeah, sure, Umar.
Yeah.
I mean, if Wei is on board, we would love to have you again, Wei, for future webinars as well. But that is something that we can then discuss. Great. But then I guess it is goodbye. Once again, thank you, Wei, and thank you, everyone. I hope you all have a lovely Saturday and a great weekend ahead. Thank you.
Thank you, Humza. That's a very great webinar. Thanks for inviting me as well. And have a good weekend. I encourage all of you to actually start working out on the worksheet. And if any issues, maybe we can have a follow-up webinar with a more guided discussion, right, on how we can calculate some of the examples that I've shown. For example, reactor sizing, for example, equation solving, for example, the mass and energy balances. That will be something that will really, really help you, I believe, as a chemical engineer. So thank you and see you soon.
Thank you. Bye-bye. Take care.